So, like we said, extrema points determine a shift in a function, increasing or decreasing. So at each one of these points, we're going to draw a vertical line through them. All right? Real quick, does this function have a line of symmetry? Give me a thumbs up if you think yes. Give me a thumbs down if you think no. For this function right here, what do you think? Good. That is a big ol' no. This does not have a line of symmetry. All right? A simple no will suffice.
I was going to say, I don't think we did that.
You gave us the wrong sheet yesterday.
What are you talking about?
The sheet from yesterday.
So, please stop talking so people can understand what I'm trying to say. And don't play with the glue sticks, please. Thank you. This is yesterday's paper, right? We got it with 15 minutes left. I told you guys to work on it. Are we all looking at the right thing?
Yeah.
We are not looking at what you just got yet. Okay? That's our new lesson later. Okay? If we're listening, there we go. Okay? So this function does not have a line of symmetry, right? It looks like it might, but it doesn't because it's all flipped around. Okay? So let's figure out where the extrema points are. Okay? We're looking for a relative min and a relative max. Who could help me out? Where is my relative maximum on this function, Alex?
Your relative maximum is point A.
Point A. What are point A's coordinates?
Point A coordinates is -2, 4.
-2, comma 4. If you didn't have the coordinates, please make sure you add them.
Oh, I thought
The maximum is at A. It's the high point.
the minimum is at C. The maximum.
Thank you, Anthony. My relative minimum is at point C. What are my coordinates for point C?
-4, 2.
Good. Just flip them around. Yep. 2, -4. X goes first. Exactly right. There's my min. I'm going to draw a line through my minimum. Now, each of those purple lines I just made indicate a change of direction, right? If we're thinking about our roller coaster, we're going up, then we're going down, then we're going up. Because we always want to read it from left to right, right? Even though this arrow is pointing down here, you guys see what I'm pointing at? Even though this arrow is pointing down, from left to right, my function is still increasing. Okay, so we'll look at the arrows today, but just think about the roller coaster. Here's your little roller coaster cart, right? And you're going up, up, up on this first little interval here, right? So this interval, we are going up, okay? What x values are included in that interval? Alex, what x values are what x values are included in this interval? There we go. That makes sense.
-5, -4, -3, -2.
Perfect. -5, -4, -3, -2. Is -1 included?
No.
No. Is -6 included?
Yes.
Yeah. Is -7?
Yeah.
Yeah. -8?
Yeah.
Yeah. You see where we're going with this? So the only x values on this section of my, or on this interval, are x values less than -2. Okay? So we are increasing anywhere there's an x value less than -2.
Oh, there we go. Yeah.
Right? Now this is where, like, conceptually we have to think about this for a second. What is happening at -2? Am I increasing at -2?
No, you're stopped.
No, right? Now, you're not stopped, but it's neither increasing nor decreasing, right? So when we identify a relative minimum or a relative maximum, those points are not included technically in the interval, right? So you may be questioning, well, can I put x's less than or equal to -2? And we can't, because at this point, my function is neither increasing nor decreasing. It's the point of change, where we change our directions. Not that anyone was wondering that, but if you were, that's why we wouldn't include it. Now this little contained section here I see is going downward. That is a decreasing interval. Right? What's my left side bookend for this interval? If I'm looking just at this interval, right? What's the far left x value? You can just shout it out. Negative 2. Thank you, Chloe. Negative 2. What's my far right interval? 2. So this interval is any x value greater than negative 2 and less than positive 2. What's that?
Let's go back.
Go back up.
I want to see.
So here's negative 2.
So only in that between is the decrease interval.
That's right. So I'll do it in little red, right? I'm not going to shade the whole thing in red. But this little contained interval from relative max dropping all the way down to my relative min, that's when my function is decreasing, right? All this little section over here for infinity, forever and ever to the left is all an increasing segment. And then in section, my third interval here, we're shooting back up. So all these x values are part of my positive interval, right? Where does this interval start on the x-axis?
2.
At 2, and it goes on forever. So any x value greater than positive 2 would also represent an increasing interval. Now you see why this can get confusing with our positive and negative. It's a very similar process. We're just kind of looking at the function in a different way. All right, so we're just focusing on this for now. We'll put it all together on Monday. Or we could put it all together right now. I forgot there was this part. What are my x-intercepts for this function? Where does this line cross the x-axis?
3 times.
Negative 4, comma 0. Where else?
0,
0,
0.
0, and
4, 0.
4, 0. Good. Where does it cross the y-axis?
0,
0,
0.
0, much like our warm-up today, yes?
Yeah.
Right? Here's an x-intercept, and a y-intercept, and an oh, you can't even see it. Right there, right? X and y, x. So now we're going to think to what we talked about the other day with my positive and my negative intervals. Okay? So I'm going to go back up. All right? What I'm going to do now, if we think back to what we did the other day, and we have 2 highlighters in our hand, hopefully you've got your 2 highlighters. If not, go ahead and grab them. Is I'm going to make a vertical line through my x-intercepts. 1, 2, and 3. Those 3 pink lines are my x-intercepts. All right? And of course, we can't forget, I'm going to draw a line through my y-axis as well. So I've got 1, 2, 3, 4, 5, 6, 7, 8 sections of my graph to highlight. All right? We're going to ignore the sections without my function. So this section, that section, that section, that section. And anything above my x-axis, I'm going to highlight in yellow. So that would be this section right here and this little section over here that goes on forever. All right, those are the only little blocks where my graph, the graphed line here, the little squiggle, actually shows up, is in those 2 sections. Give you guys a moment to do that. Then I want to look below my x-axis, and in my secondary color, whatever it may be, I'm going to highlight this section over here to the left and this self-contained section that includes my minimum point C. So our graph should look like this, where my little squiggly line, my roller coaster, is only passing through highlighted sections. Right? We're under the x-axis, we go over, we go back under, we go back over.
Oh,
So my yellow sections are my positive intervals. My pink sections are my negative intervals. So this pink section right here, is any x value less than what? Negative 4. Right? Negative 4, negative 5, negative 6, all the way over. Is any x value less than negative 4? So for my negative intervals, I've got x is less than negative 4. Again, we're not including the point negative 4 because it's on the x-axis. It's neither above or below. I also have a negative interval right here, this little pink section. What two x values is that pink section in between?
0 and 4.
0 and positive 4. So any x value greater than 0 but less than 4. And my positive intervals, if I look up, I've got this blocked in section right here. What x values does this yellow section fall in between?
Negative 4 and 0.
Well, my far left is negative 4, all the way over to 0. So I have a positive interval for my x values greater than negative 4 and less than 0. And anything greater than positive 4 is also going to be positive, as we see up there. So x is greater than 4. Isn't that fun?
Maybe.
Our definition of fun is
I think it's fun.
That's not fun. Yeah, I think it's fun.
Maybe you guys have a different definition of fun.
yeah.
Our fun is
I just don't
our
know.
fun is sleeping.
No, our
You'll have plenty of fun this weekend then, but not right now. Any questions I can answer about that?
No.
Okay. Don't worry.
I have a question.
Yeah.
So the way that you find like the numbers on the plot, so it's basically like wait, I'm trying to figure it out because like you got 4. I know the way that you got 4 was because that's where A was located. Or no, you got it because that's where C was located. And
Yes.
You got positive 4 because that was where A was located, right?
Right. So here, I think I know where you're going with this, right? So when we're finding the interval for increasing, decreasing, what we talked about yesterday, we're focusing on the extrema, the relative min and the relative max. So at 2 and negative 2, right? That's where I find my increasing and decreasing. But when I'm finding my negative and positive, I'm looking at where I cross the x-axis, my x-intercept.
Oh.
So it's like my x-intercepts help me find my positive, negative. My maximum and minimum help me find my increasing, decreasing. It's like two completely separate ideas that just so happen to be very similar to one another. Yeah.
That makes sense.
Okay, good. We'll get more practice with it later. Let's get the easy stuff out of the way. Go ahead and flip over to end behavior 3.5b. End behavior
The end of an era.
describes the values of a function at the positive and negative extremes in its domain. Now, when I'm talking about the domain, am I talking about the x values or the y values? The x values, right? And it says so right there. Just like with everything we've been talking about, my x values are what's the most important.
Oh no, negative is supposed to be 3.
I don't know why there's an apostrophe after look. My bad. But all we're going to do with this work is look for the arrows on the ends of your function. It's going to be very, very simple. Okay? So let's take a look at this first parabola here. Let's just jump right in. Go ahead and point to your left arrow on this parabola. Where's your left arrow? You can point on your paper. Right there, right? It's my arrow on the left. Every one of these functions is only going to have 2 arrows. A left arrow and a right arrow. So my left arrow, is this left arrow going up or down? It's going up. My left arrow is going up. Everybody points to your right arrow. Where's your right arrow?
Right here.
It's right there. Exactly. On the right, right? Right. So, what direction is my right arrow going? Up or down? It's going up. Look at that.
Isn't this where we learned about the mirror?
Not quite. Just stay with me, okay? So, just looking at this graph, right away you can see, oh, both my arrows are going up. Give me a thumbs up if you agree with that, right? You can look at it and go, oh, both my arrows are going up. Yeah? Okay. So, what this means, as x increases, okay, which means as we're going to the right on my x-axis, right? My x values are 1, 2, 3, 4, 5. That's my x increasing, right? As my x increases, my y is also increasing because we're going up. That's how we know. As my x values are increasing, we can see clearly that my y values are increasing as well, because the further we go to the right, the further up we go. It's like a double increase, right? Give me a thumbs up if you see that real quick. Okay. Now, what is happening as x decreases? Well, as we're going to the left on my x values, -1, -2, -3, as we're decreasing, what's happening to my y values here?
Decreasing.
They're what?
Decreasing.
Decreasing? Well, are they going down? No. So what does going up mean? Increasing. Take a look. As we're going left and left and left on this graph, my left arrow is still going up. Okay? So the first scenario we could have for end behavior is a double increase. We know that we're going to have a double increase when both my arrows are pointing up. Right? How we doing with that, okay?
Yeah.
Yeah?
Nice and slow.
Okay. Let's look at the second scenario. Everybody, this is I don't know what this shape is called. I just call it a squiggly. So if you're looking at this squiggly, point to your left arrow real quick. Where's your left arrow?
Down. Bottom.
On the left. What direction is that arrow pointing? Down. Ooh. Okay, let's not get ahead. Everybody point to your right arrow.
This one.
What direction is your right arrow pointing? It's pointing up. Now let's figure out the behavior. As x increases, so again, as we're going further to the right on my x-axis, what's happening to my y values?
Goes up. Increases.
They're increasing because my arrow's pointing up. So as x increases, y increases as well. Now as x decreases, as we go to the left here, what's happening to my left side of the function?
It decreases.
It's going down. It decreases.
I got it right.
Good.
Let me try and get all
That's crazy.
Everyone should stop yapping.
Well, I mean,
Except for me. It's my job to yap.
I should become a teacher then.
You shouldn't. You'd be great at it. So, this next one here. We got a nice line. Or, sorry, does that second one make sense?
Yeah.
Okay. We're just following the arrows. It's pretty straightforward. For the second one, everybody point to your left arrow. What direction is your left arrow going? It's going up. You might be like, oh, it's going to the side. Well, it's going up and to the side, right? So it's going up. What direction is your right arrow going? Down. So as my x values increase, what's happening to my y values now? They're decreasing. Take a look. As I go to the right, my function's going down. So as x increases, y decreases. But what happens as my x values decrease to the left? Where's my arrow going now?
The y is increasing.
It's increasing because my arrow's going up. So as x decreases, y increases. I'm realizing now I should have flipped these around so that the colors matched, but you live and you learn. Finally, my last one. What direction are both my arrows pointing?
Down.
They're both pointing down. So I know that no matter what x is doing, whether it's increasing or it's decreasing, what's happening with my y?
It decreases.
Well, yeah, they're both going down, so it's both decreasing, right? I know this takes a little bit of thinking.
That's a lot of red.
It's not a lot of writing, it's 2 words.
A lot of red.
Oh, a lot of red. That's right.
I mean,
So as x was increasing, my y decreased. As x decreased, my y also decreased. Four scenarios. We could have increase, 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 decrease, decrease, increase, decrease, decrease. These don't even sound like words anymore. I'm saying so
that's
much.
the only ones,
Sounds like cheating.
only possible ways.
It's the only 4 possibilities here.
So it's a 25% chance.
W.
Yes, you have a 25% chance of guessing these right. Unfortunately for you, it's not the only part of the problem.
25%.
Because we didn't have a worksheet yesterday, did we? So what we learned yesterday is going to be part of it too.
Good.
All right, that's why it's 3.5A and 3.5B. It's the same lesson.